Section 4.4 is dealing with parallel and perpendicular lines. Parallel lines are lines that never cross. Parallel lines have the same slope because they're going in the same direction. So, for example, if you had one line that had a slope of 2/3, what would the parallel line slope have? And this is a symbol for parallel. The parallel slope would be also 2/3 because they have the same slope. Perpendicular lines are two lines that form a 90-degree angle. Perpendicular slopes are opposite and reciprocal. Notice how I put in big caps and. That's where a lot of people make their mistake. They do the reciprocal, but they forget to do the opposite. It's opposite and the reciprocal. For example, if I told you that one line had a slope of 2/3, the perpendicular, abbreviation for perpendicular is an upside down T. A perpendicular slope is the opposite. So what would that be? Negative, and then when you take the reciprocal, so it would be -3/2. Example 2a, determine the parallel and perpendicular slope of each of the given lines. Well, very first thing we have to do with this equation is we have to find the slope of this equation. How do we find the slope of this equation? We have to put it in slope-intercept form. We have to get it in this form. Is it in that form? No, so we have to get it in that form. How do we get it in that form? Add x to both sides. So that's 2y is equal to x plus 6. Divide by 2. So what number is in front of that x? A 1. So that's 1/2 x plus 3. So what is the slope of this equation? 1/2 x. So this is the equation of this line is y equals 1/2 x plus 3. The slope of this equation is 1/2. What would the parallel slope be? Parallel has the same slope. So what would the parallel be? 1/2. What would the perpendicular slope be? -2/1, but we would just say -2. Remember, if you have 1 in the denominator, you don't have to write it. The only time you have to write the 1 is if you were counting by rise over run. Okay, so you can see these two lines. You don't have to copy this graph. Just look at these two graphs. The very first graph, are these parallel lines? Yes. Let's count and see what the slope is. Let's go to this one. It crosses right there, so we went down 1 to the right 3. Let's do it again. Down 1 to the right 3. So what is the slope of this line? Down 1 means negative, and to the right 3. So it's -1/3. Let's look at this. If we go down 1 to the right 3, down 1 to the right 3. So the slope is also -1/3. Is that correct? Yes, they're parallel. Parallel lines have the same slope. Now we can look at the second graph and we can look right away. Are they parallel? No, I think they're perpendicular. If they're perpendicular, they would be opposite and the reciprocal of each other. So let's identify the slope of each line. Let's look at this one. I'm going to call that line 1. I always write my B. Let's see, I went down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I kept landing on the line. So what is the slope of line 1? Down 2 to the right 1, which is -2. Okay, let's look at this line. What's the slope of the second line? I went up 1 over 2, up 1 over 2, up 1 over 2. So up 1 is a positive, and over 2, right? Now compare these two slopes. Are they opposite and the reciprocal of each other? Yes. So they are perpendicular. Okay. Same directions Example 3 has the same directions as example 2. Before we can determine the parallel and perpendicular slope, what are we going to have to do with this equation? We have to find the slope of this equation. Is the slope 2? No. We have to put in a slope-intercept form to find our slope. So we have to solve for y. So we subtract 2x on both sides. So that's negative 3y is equal to negative 2x plus 6. Divide by negative 3. So y is equal to positive 2/3 x minus 2. So what is the slope of this equation? 2/3. What is the parallel slope? 2/3. What is the perpendicular slope? Opposite and the reciprocal. Negative 3/2. Y'all agree? Okay, y'all do example B. So the equation is y equals 2x plus 4. What is the parallel slope? 2. Remember, parallel has the same slope. The perpendicular slope is the opposite and the reciprocal. So that would be negative what? 1/2. Okay, example 3C. Determine the parallel and perpendicular slope of the given line. So what we have to do first is we have to determine the slope of this line. Now, I always like to start at my y-intercept, my b. You don't have to. You could start at any given point. It doesn't really matter. We're not coming up with the equation of the line. We're just finding the slope. So we can start here and go there. So we go up 2, 1, 2, 3/2. Do it again to make sure. Up 3/2. Up 3/2. So what is the slope of this line? We went up 3/2. So my slope is 3/2. What would the parallel slope be? 3/2. What would the perpendicular slope be? Negative 2/3. Okay, example 1a. Write an equation in slope-intercept form that passes through the point negative 3, 5 and is parallel to the graph y equals 2x minus 4. So let's graph this equation, y equals 2x minus 4. So if we were going to graph this, the slope is 2/1, your b is negative 4, which is the ordered pair 0, negative 4. So let's graph this. Plot 0, negative 4. We're going to go up 2/1, up 2/1. Now, we have to come up with an equation that's going to go through this point, negative 3, 5, that is parallel. So parallel means we use the same slope. What is the slope of this equation? It's 2. So we're going to use that slope. So we're going to plug it into the point slope formula. So that's y minus 5 is equal to m is 2 times x minus a negative 3, which is plus 3. Now, are we putting this in standard form or slope-intercept form? Slope-intercept form. So we're going to do the distributive property. Add 5 to both sides. So y is equal to 2x plus 11. Now, let's just graph this to see if we do get a parallel line. The slope is 2/1. Your b is 11, which is the ordered pair 0, 11. My graph is just I'm going to go a little above. Now, instead of going up 2/1, because if I go up 2/1, I'm going off my graph, what should I do? Make them both negative. Down 2, backwards 1. Okay, now are these graphs parallel? Yes, you can clearly see that they're parallel. Now look at the second graph that we just drew. Did it go through this point, negative 3, 5? Let's plot. Where is negative 3, 5? 1, 2, 3, 1, 2, 3, 4. Yep, here it is, right here. And went through that point. Now, on your homework, you're not going to have to graph. You're just going to come up with the equation. I'm just showing you the graph because I think a visual picture helps to make you understand it a little bit better. Okay, this equation is already solved for y. So what is the slope of this equation? 1/4. So we are going to come up with an equation of the line using this point and the same slope. So that's y minus a negative 1, which is plus 1. M is 1/4 times x minus 4. Now 1/4 x times negative 4, that's a negative. If you need to go to the side and multiply, that's 1/4 times 4/1, which turns into what? 1. Okay? Subtract 1 on both sides. Y is equal to 1/4 x minus 2. So this equation and this equation are parallel to each other. Determine whether the graphs y equals 5, x equals 3, and y equals negative 2x plus 1 are parallel or perpendicular. Let's graph all three of these equations on the same grid. Y equals 5. What kind of line is that? That is a horizontal line at 5. And x equals 3, that is a vertical line at 3. Now to graph y equals negative 2x plus 1, the slope is negative 2/1, and your b is 1, which is the ordered pair 0, 1. So we're going to go down 2 to the right 1, down 2 to the right 1, or up 2 and backwards 1. Now tell me something about these lines. Are any of them parallel? None of them are parallel, are they? Are any of them perpendicular? Which ones are perpendicular? The horizontal and the vertical. All horizontal and vertical lines are always perpendicular to each other. Now what about the third equation, y equals negative 2x plus 1? Is that line perpendicular or parallel to the other? No, they're just intersecting. They cross, but they don't form a 90-degree angle. They're just intersecting. So y equals 5 and x equals 3 are perpendicular. Okay, example 3b. Just copy down these three equations. Determine whether the graphs of 6x minus 2y equals negative 2, y equals 3x minus 4, and y equals 4 are parallel and perpendicular. The very first equation, 6x minus 2y is equal to negative 2. What do we have to do here? Get it in slope-intercept form. So that's the first thing we have to do. So let's do that. Divide by negative 2. So y is equal to 3x plus 1. So let's graph that, and I'm going to label that, that's y sub 1. I'm going to put a little 1 so I can distinguish between the 3. Up 3/1. Now the second equation is already in slope-intercept form. So I'm going to plot 0, negative 4, up 3/1, up 3/1. I already know what's happening with these two lines. They are parallel. Do I even need to graph it to see that they're parallel? No. How do I know that they're parallel? They have the same slope. So y equals 3x plus 1 and y equals 3x minus 4 are parallel. What about y equals 4? That is a horizontal line at 4. Is this line parallel or perpendicular to anything? Nope. They're just intersecting. Okay, we have to find the slope of this equation. Is this equation in slope-intercept form? No, we have to get it in slope-intercept form. So we have to subtract 2x then divide by 3. So y is equal to negative 2/3 x plus 4. What is the slope of this equation? Negative 2/3. But we need to find the perpendicular slope. So what is the perpendicular slope? Opposite and reciprocal, 3/2. So we're going to use that slope and this equation and come up with the equation of the line. So that's y minus 6 is equal to m is 3/2, my slope, my perpendicular slope. Remember, we have to get the perpendicular slope. So that's x minus a negative 4, which is plus 4. Now, we have to put this in slope-intercept form, correct? So we have to do the distributive property. 3/2 times 4. If you cannot do that in your head, go to the side and multiply 3/2 times 4/1. We cross reduce, and what do we get? 6. And then add 6 to both sides. And y is equal to 3/2 x plus 12. If we graph these two equations, would they be parallel or would they be perpendicular? Perpendicular. Okay, to save some time, we're not going to graph. Example 4b. What's the slope of this equation right here? 2/3. So what do we use, that slope, or do we use the perpendicular slope? The perpendicular slope is negative 3/2. So we're going to use that slope and this point and plug it into the point slope formula. We're going to do the distributive property. Negative times a negative is a positive. Again, if you need to go to the side and multiply, 3/2 times 4/1. What do we get? 6. Add 7 to both sides. And y is equal to negative 3/2 x plus 13. And there it is in slope-intercept form.